Okay, so I'm going to share my screen too. So I should share this one. So I will make public project 2 now in a second, but meanwhile, you can have a look at this one. This is in index. Let me see. This is, sorry, this one, okay? Course 3, second example. So I will have a look at the map part of this. I know probably we already discussed some of this with Giacomo, but we can have a look again. And if any of you has some questions, I will talk a little bit about this code, especially the map version and how to use closures to basically pass parameters to maps. And it's a way of playing a little bit with the visibility of variables. Some people do that by making functions and return functions. That also works. But this is another way which I think is elegant and a little bit simpler to understand for many people, I think. Then, hopefully, if we have time, I will have a look at, in project 1, this second part, the use of profilers. Okay, basically, I want to just have a look at what the profiler returns and how we can think and how we can improve one function. Okay, so that's what we will be doing today, unless there are many questions suddenly, which I don't think will be the case. But first, let me publish project number 2. You will be able to have a look at it too. Let's do that. You will not see it in the screen at this moment. Okay. Okay. So let's see if I can show it here. Yes. So this is the second one, the second project that we will do for the course. The course has 3 projects. Number 1 is about processing structured data, so Excel-like type of data. Project number 2 will be about image processing without deep learning. Okay, so in this one, we are going to be doing things like counting pixels and seeing how counting pixels combined with expert annotations can help us get quite a lot of useful information from our data. Okay, and this whole thing, I will not go into it into detail, but just to have a look, starts with a download of the data. The data is quite different, and you have an initial part where I try to have a look at the different files and so on. This cell here is an exploration in text of the structure of the files and folders. I think this is cool as a way to use pandas and pandas classes and so on to see what the file structure of a folder is. This is just a curiosity, not super necessary to do the exercise, okay? But you end up with something like this. So we have different sites, and for every site we have many files. They are all image files. There is one where we have mosaics, which are we will explain this in detail. Images of large areas with or large areas of a forest with high resolution. And then we have lots of expert annotations where each species present in that forest is in the form of a binary mask, and also where the treetops are in all the treetops of all the species are. So we have all of this information, quite a lot of it, and we have it somewhat mixed. So we will do code to extract as much information as we can. And we will start with very, very simple things like loading an image with OpenCV, be it a color image or a binary mask. And then we will do several tasks to manipulate and to get information from those images. I have divided the tasks into kind of 3 levels of difficulty, okay? D1, D2, and D3. D1 means that everyone should be able to do it, okay? Even beginners, it might take some time, but these are supposed to be not difficult. D2 are the ones that should be done later by beginners and can be already quite challenging for them. And for advanced students, they should still be pretty easy. And finally, D3 are the ones that can be challenging even for advanced students. As usual, let me know if you have any questions. You can get as much feedback as you need from me, and you can submit as many times as you need. Absolutely no problem. Okay. There are many tasks in this second project, probably too many to complete. Okay. I wanted to give a wide range of things that can be done. Okay, but don't go crazy with this. If you can complete, for example, for beginners, D1 and D2 tasks, that's more than enough. And for experts, if you can do most of D2 tasks and maybe some of the D3, that's also fine. Okay, I think they also provide a gradation of things that we can do. We start just opening an image, which for an expert should be pretty simple. We continue with tasks that can be a little bit more involved, where we have to process many images in different folders and combine them to get the information that they share and get rid of the information that they don't. We then can do some things like data sanity checks, like finding common points in annotations that are wrong. This can be a little bit involved. All of these things can be really, really slow if we just use classical programming with loops and so on. But by using the NumPy function, the NumPy library, these things become much faster. So we will talk about that too. Okay, and we will end up with census type statistics. Then we can combine that with pandas. We can get the information, hopefully with NumPy, get a table with the information that is actually contained in the images, and then visualize and process that with pandas too. And then we can do, well, some other things. That's for this data. At the end of the project, there is some more information with, there is a couple more tasks with different data, okay, from volcanic eruptions and so on. And this is just to show that similar code and similar techniques can be used to do different things. But this one, again, challenging. And here I'm asking you to not only visualize the annotations and do things like count pixels, but actively use functions that do something else. For example, in this case, we want to separate these craters. These are volcanic impact craters, and we want to separate the ones that have gotten mixed up, that have gotten overlap. Okay, so we want to use first the connected components with the stats function to count these craters, and then morphological operators to separate them. Both things are not super difficult. They can be achieved with a pretty straightforward use of these functions, but you have to understand how to use library functions, what they do, how they work, their finer parameters, and so on and so forth. Okay, so I hope you will have fun. Many things to do, and as I was saying, please do not get too stressed out. Okay. Okay, so that's project 2, and you can have a look. If you are already tired by project 1 and prefer to just relax and have some look at some code, I will start with this one, talking a little bit about maps, and then I will move on to do a little bit about profiling, okay? And talk a little bit about how one of the profilers that can be used in Python works, and how we can get some, how we can use it to improve our code. Okay, but before that, let me just for a second check if there are some submissions, give some feedback, and see if there are any questions, either in web class or in Slack, and then I will continue with this. If you present here have any questions, there are at this moment only 2 of you, so please feel free, okay? Private lessons. Okay, so took a while, but I have finished giving the feedback for all the submissions that we had. I will have a look in about 20 more minutes in case anyone else submitted in this time. As far as I can tell, there are no questions either in Slack or in web class. Let me check web class again, just in case. And yeah, we do not have any questions at this moment. So I will go on to this first description of the, sorry, about commenting about this maps issue and what the difference is when using maps and closures. Okay, so I'm going to use this example code. This code comes from um, an exam for the second subject, the second programming subject that I teach here at the Faculty of Science in Yamagata University. This is from data structures and complexity type of course, and this was the final exam, I think, a couple of years ago. Okay, so let me make a new notebook and then start by just downloading the data from this one. So the data in this case is okay. The data in this case is a CSV file with entries regarding people. Basically, this is some sort of, this is originally from Kaggle. So this is a realistic or realish type of data set with information about workers of companies. Okay, and we have their names, genders, emails, phones, date of birth, and most importantly, their job title. So we are going to manipulate those things. But as we have been having here, we have structured data. Okay. First thing we did was download the CSV file. Second thing we did was create something called a named tuple. In this course I have been mentioning, we do not yet do object-oriented programming. We do that in the following subject. So instead of that, here we use named tuples, which basically are just regular tuples, but you can then give names to their fields to make the code a little bit more easy to follow and easy to read. Okay. The students received these couple of functions that processed the file into a list of name tuples using pandas. Okay, so I can print people list, and I can even print people list of 0, for example, to see what every element in that list contains, and we see that each element in the list is one of these named tuples, which just contains the information from one person in this format. So we have all these fields, all the fields for this for each person, with the identifying names that we have given each of the fields. Okay, so basically, as you are advanced students now, let me just call your attention to these iter tuples, which this function uses to traverse pandas data frame, and how we do this yield thing. Okay, which allows us, this results in an object in Python called an iterable, and then we get this, which is something that allows us to iterate over the result of this, and then we feed that to a list constructor. Okay, so basically this goes over the data frame, sets up everything in this name tuple format, Okay, the name tuple, we get it as a parameter. Okay, so I could process this with different files and different name tuples. This is also one more level of abstraction, which can be interesting. Okay, and if you are not following it, really do not worry. And then this yields an interval, the results, but not with return, but with yield in something that can be iterated and that we fed to a list constructor to end up with this people list. Okay, so already here quite a lot of advanced processing, but not something that the students had to do for the exam. Okay, here we printed some things. Let's see. Yeah, we will do first task A, and then we will go to some of the other ones. Task A, we wanted to find some specific criteria. A person of female gender who has a job title that contains the word music, okay? So that's what we wanted to do. And that can be quite simply done with something like this, okay? Let me copy that and let's just run it. I will not type it again because I think you both understand this one pretty easily. So now I just will call it. What does this function do? Okay, it basically has a search loop in it with this classical structure of search loop, Boolean to see what when I have found what I'm looking for, and then otherwise an index to see if I have reached the end of my list. Okay, and then I'm checking this information. The gender has to be female, and music has to be in the job title string. Okay, the last string in the named tuple. Notice that I'm using these names that I have to the fields to access them. I could also do, instead of my list point gender, I could do, because this is also a tuple, gender is the 0, 1, 2, number 3 field. So I could also do my list of I of 3. That would also perfectly work. Okay, but as I have taken the time to define a name tuple, I will just access the fields by name. So pretty simple search loop. But here you can do it also. We can do it with pandas, of course. Pandas just filters. Let's copy that one too. Sorry. And then I can call this one. Sorry, how did I call the data frame? My people data frame. Okay, this one, of course, it's pandas, so it doesn't receive the people list, but it receives pandas data frame. Okay, and in this case, I have outputted all of them, and I can check that the first one that I generated before is also here. So I would need more coding to check that both things do exactly the same thing, but that's at least a good sign. Okay, here I'm just selecting. I'm doing a regular pandas query with ands and so on. So I have used this to get rid of all the registries of all the rows where the gender, the sex is male. And then this one I'm calling the contains function in all of the results of this search. Okay. And then I outputted this as a list. If I want to do exactly the same as before, I would probably need to, can I just call this with 0? Yes, I can. Okay, I'm just outputting now the first one. Okay, so a couple of simple solutions. Pandas is very well suited for this as for many, many things. But let's have a look at this with a map, okay? Sorry, not this one. Let's find one with where we can do a map. Maps are not very well suited for searches because maps are typically used when I need to do the exact same processing for every one of the registries, everyone in this case of the rows that I have. Okay, so let's have a look at task B. In task B, we just want to count something simple. How many people in people list have Sarah as their first name? Okay, first name is one of the fields that I have defined in my name tuple. Okay, field number 1, 0, 1. And I want to see how many times that one is Sarah. Okay, so let's see here. This will be task B. And now let's check the code for that. So again, simple version is just a loop. In this case, it's not a search loop, but a traversal loop. Okay, I'm going to receive one list of tuples, the people list list of tuples, count names of people list. Okay. Okay. So sorry, I have to give it the name that I'm looking for. And here is my count, okay? In this function, I receive a value that I want to look for, and then I receive a list of tuples, and then I just check whether with a traversal loop for every tuple, if the first name is the value that I have received. If I want to see how many people in that list are called Iago, I, not surprisingly, get the result of 0. Some name that might be there, I don't know, Mark, yeah, 11 marks, okay? Simple traversal loop. How do I do that using a map? I can do that with pandas too, okay? And I can do this with a little bit of a more general approach. Let's have a look for this one. So here it is. Instead of just receiving the value and just checking the name, I can get the value as I said before, but I can get the field name, okay? Then I can check any attribute, but I cannot just access top dot field name because that will be mistaken for the name of the variable. So I have to use this get attribute. Okay, get attribute, you give it the name of an attribute and then it looks for it. So if I count field of, sorry, I will probably have that type here. Yes, of the name of the field, that will be faster. If I count the number of, sorry, I put it in a text cell, which was not helpful. Let's just run this one, okay? I have not defined it because I have not run the previous cell. Now I have it, okay? Let's go back to having Sarah here, or let's just put Mark there, okay? Okay. So I have the function that does a similar thing to what the one before did, but now I can get my name, the name of my field here. And then I can not only check first names, but I can check what other fields did I have there. Sorry. Sorry, not here. I have defined my names in the names tuple. Okay, so I can check for people name, I don't know. Instead of checking for first name Mark, I will check for last name Brown. Okay, 8 Browns. Or I can check for what happens if I input a field name that doesn't exist. Okay, I get an error. Okay, So I think I have one called job title, and then I will look for what accountant in job title. I don't have any. Let's see what job titles I have, and let's check that that also works. Job title was there. Is there? Okay, hematologist. That one is cool. Okay, so let's look for hematologist in our list, people with that job title. 21 of them. Okay, probably medical company. Okay, so basically, I have just something that does a traversal loop on my list of tuples here. But I can do that also with a map. What is a map? A map is basically is a functor, an operator, something that uses functions as their parameters. When I use a map, I need an iterable and a function, and then I can iterate over all the elements in the iterable using the functions. Okay, so for example, let's define a simple function here, double, and then this doubles. So I return twice x. Okay, this is a very silly function. And then I can just define an iterable like range from 3 to 27, jumping at intervals of 4. Okay, and if I do that inside of a list, then I will get this particular list. Okay, so I can combine the two things using a map. I can map the double function. Yes, that's very helpful. In this case, Gemini is saying with that range. Okay, and the first thing that I get is a map object. Okay, which is not very helpful. A map object is something that I can also iterate. So the map itself doesn't do much more than prepare me to fit this into something else. So I can usually fit this to a list. So I get this object that allows me to iterate things, and I can then turn it into a list, for example. And then I get a list that's double. Let me print the ones that I had before. The list that I had before. Okay, so I have gone over all the elements in this list using this function. Okay, and then I have obtained this list. Now let's instead of do double, I'm going to still call it double, but I'm going to now use square. And now I had all the elements squared. Okay, whatever. I can use this map operator, this map, which is one of the functional programming functions that Python has built in to process one iterable and apply the same function to all of its elements. Okay, so pretty simple for these kind of things. Maps are also fast because they work always in the same way by accessing all the elements in something in an iterable and then applying always the same function. This can be parallelized, and this can be quite fast. But I have a slight problem. What if my function receives more than one parameter? Okay, so what if this was a multiplication function and I have one factor, and what I wanted to do was something like factor times 2, and this was something called multiply. Okay, extremely silly function because I can just do this on my own. But my point is, what if I had one function with parameters? Then I could not call map, because every time map went to call that function, I would get this type of error. Okay. So there are quite a lot of things that I can do. I can, for example, just define a global variable. Okay. Maybe this factor is something that everyone knows about. So let me do 2, for example. Okay. So, but I don't have to pass it as a parameter because otherwise it's missed. I declare it as a global function. Okay. So now this factor is visible here because this inside of the cell is like a global variable, and then I can do it, and then I can change this times 5, 6. Okay. This is a pretty dirty way to do it because Jupyter notebooks have lots of problems with visibility. So if I now change and go to another cell, this variable might get lost. So a simple way to do this is to enclose all of this processing that we are doing. This is not part of the processing, so let's get rid of it. To enclose all of this processing that we are doing inside of one function. So let me define an outer function called processing. And inside of this function, I will do the thing that I was doing. Okay. And then, sorry, I missed the semicolon here. My global variable stops being a global variable and becomes just one variable of my processing function. Okay. Notice that I have an inner function that is what the map calls. And then I use my factor variable here as a way to define it inside of, as a variable that's seen by all the functions defined inside of the larger function. Okay, so I'm playing with the visibility of things here. There is another way to do this, okay, which is by returning the function. So I'm going to have a function creator which will receive a factor. Okay, sorry. Let's change the name of the variables. I'm going to call it value. And then here I'm going to have a function multiply, which will only have one parameter x, and then this one will return factor times x. Okay, and then this function creator will return multiply. Okay, so that is another way to do it. I will first get this value that comes from outside, put it in this factor variable, then I will create this multiply that will have this value here incorporated inside of it because it can see it. It's in a higher range of visibility, so it can be seen inside of this, and I will return this multiply function. And then I can just list map, what did I do? This function creator of whatever function, whatever factor I want to create, and then the iterable that I had somewhere there, range. Okay. Okay, and I get the exact same thing that I get before. Sorry, I haven't called this one. I have to call processing. and I can return this one. Okay, so as process, my factor was 5 here. Let's put it at 7, and I get the exact same thing. Okay, so that was pretty quick, but let's recap for a second. I went and created, I checked, I explained a little bit what maps were. Then, first of all, I did everything, let's say, in just a cell of a Jupyter notebook, and I saw how the visibility helped me get rid of the need for more parameters. Okay. Then what I did was encapsulate the whole processing in one function. I will define the function that will do everything this way, and then have an inner function that will do whatever I want to do for every element of my iterable. Then, to give this function as many variables, as many parameters, as many inner variables as I need, I will define them outside, but they will be visible here because this is one environment of visibility higher than this one. Okay, so this function factor is kind of global respect to this inner multiply function. Okay, so with this, I will already be able to call map on them. And this can be achieved in the same way by having a function that returns a function. So I do the same thing. I have an inner function. I define as many variables as I want here, global to this one, higher range of visibility, okay? And then instead of doing the processing here, I return the function with its parameters, and then I do the processing outside, okay? Pretty similar ways to do it. And here in this example, we have an example of how to do that, okay? So what did we do here? We were counting fields. Okay, we have this function. So I'm going to have a function that receives a field name, a list of tuples. So this is similar to this type of processing. I will receive a field name, the list of tuples, and a value that I want to check. And then I'm going to have an inner function that gets the field name from the visibility environment here. And then it will just see if the field name with the value, if the field name at each point fits the value, okay? And I can just call this count field map of what were we checking? Yes, job title, people list, and hematologist. And something happened with the indentation there. Yes, you're right. Okay. And then I get the same result as I had before, okay? I have this map here that calls at every point the fits field function and then gets this get attribute here, okay? Pretty advanced stuff, but the message here is basically that you can get very, very efficient code and very, very fast code using these maps, okay? Minor thing here, I have a sum instead of a list. Yeah, so far I have always been using list, but here I have a sum, okay? Can you see why? Have a 1 minute, have a look for 1 minute. Taking the opportunity to check if there are any questions meanwhile. At this moment, there don't seem to be any. No. Let's also check Slack, but everything is fine. Okay. Okay, so we have a sum instead of a list here because the previous goal was to do something and put it inside of a list. Here we want to count. So instead of creating a list of anything, we are actually creating an iterable of Boolean values. So the result of this function is either true or false. Okay, so either get attribute of X and field name is the value or not. Either the job title of each one of the register is hematologist or not. If it is, this will return true. And if it's not, it will return false. So what I will get is a succession, an iterable of Boolean values. So I could just list this. Actually, that's pretty simple to check. Okay, false, and then there must be inside of there 21 truths also. Okay, can we see any of them? Well, not so easy, but we have counted them before. Okay, here it is, one true value. Okay, but instead of returning the list and then maybe counting the truths in the list, I can just sum them, because as it happens, by default and by definition in Python, true is evaluated to 1 and false is evaluated to 0. So if I just add up all the elements in the list, the truths count for 1 and the zeros count, the false count for 0. So I get the number that I'm looking for. Okay, so that is what I wanted to tell you today about maps. Okay, let me see. Yes, here in the final tasks, you have more uses of maps, okay? You have some tasks where dictionaries are built, and these are default dictionaries, and to update default dictionaries, which have lists as their values, here we use maps. So have a look at those, because those are also interesting and a way to add a little bit more efficiency to your code. As I said in last session, efficiency in classical programming is measured in asymptotic cost. So the number of times you enter or don't enter loops, basically the number of times, the order of times you run instructions in your code. But in Python, a very important part of it is how well your code parallelizes. So if you use lots of for loops, your code will be equivalent in terms of classical asymptotic complexity, but it will be slower in runtime. If you try to do your best to use things like list and dictionary comprehensions and functional programming, maps, filter, reduce, then you will get code that runs that much faster, okay? That incidentally, you have some examples of the runtimes and so on somewhere here, for example, the efficiency for loop, list comprehensions, and maps, okay? Okay, so that was first thing. As I see, there are some new students that have joined a little bit later. Let me just quickly say that I have published project number 2. Okay, so I will not be entering into it in detail, but it's in web class. You can check. We will be doing lots of image processing in the next 4 weeks. The project has been published in English only at this moment. Remember, if anyone needs the Japanese version, let me know. 本当に本当に本当に遠慮しないで、今プロジェクトに発表しましたと、誰かが日本語のバージョンは本当に必要だと思ったら教えてください。翻訳することは可能です。みんなに英語を使うことを応援してみているんですけど、誰かには英語のバージョンだけやることは問題なら教えてください。それは私には問題全然ありません。This also has a provisional label attached to it. So initially I'm allocating 4 weeks to this, but that will depend a little bit on the response that I get from you and so on. This, I think, is a little bit, it's a little bit more difficult in the sense that will be a little bit unfamiliar for many of you. Maybe pandas and general data processing is something that most people have already encountered, and the image processing might be a little bit more new. But at the same time, I think the complexity of the code is not high. For the last project, project number 3, we are going to be doing some deep learning. And for beginners, we will keep it really simple, and I will ask you mostly to just use the deep learning code. But for advanced students, that can get to be quite complicated. Okay, so this code should be more or less, I think, simple. So I hope that we can all complete it in 4 weeks. But we will have a look, and if that needs to be revisited, I will let you know. In any case, at this moment, I have allocated 4 weeks. The deadline is not on the Monday, but on the Tuesday after. So you have 1 day after the class to the last question class to process the whole thing. But let's think on it. The deadline date will never go forward, so it will never be shorter than that, but it might go a little bit backwards if the progress from the students is a little bit slower than expected. Okay, so project 2 has been processed for those of you that have joined a little bit later. To finish, because we only have 10 more minutes, I wanted to go and check the use of profiling tools. Okay, so let me make a copy in Drive of this too. Internet is not going super fast at this moment. Hopefully we can manage. Yes. So again, this is project number 1, and I wanted you to check the second part, which some of you have already completed, but many of you have not. Okay, so I think the line profiler is already there in Python. This is here basically in case someone downloads this and is trying to use the notebook in their own computer, because line profiler is not installed by default. Okay, but let's install it. Oh, yeah, see, it was not there. So nice, we are installing it in Colab. One day, hopefully in a couple of sessions, I will speak a little bit about pip and installing packages in Python. I'm also going to import some time measuring libraries. And here I'm just going to run this cell that contains several functions. Okay. Okay. Then I'm going to call them with a couple of functions, and let me just load and run the line profiler, and then we will have a look, and hopefully I can tell you a little bit about what I'm talking about here. Okay. Okay. So what we have here is a series of functions that do several things. So basically, we have a function called palindrome, which does what is written in the label. Returns true if if one string reads the same back to front and front to back. Okay. So AAA is a palindrome and ABC is not. Okay, and there are some famous palindromes and so on. Contains receives 2 strings and returns true if S2 is contained in S1, if S1 contains S2. Okay, and just the func does quite a lot of things. It basically processes code and searches and calls the previous functions. Okay, so I call this just a func for a couple of strings that I have here. The first one is pretty short, and the second one is very long, and I get this wall time of 349 microseconds and this wall time of 405 microseconds. Okay. I will not stop too much into this wall time and user time. Basically, well, it's actually quite clear here. It's a difference whether or not the computer was using the processor for what I am doing or if it was doing system things. So every time we try to use our computer, our processors might be allocated to something that the system needs to do. So the time that elapses and the time that has been spent doing our calculations are not exactly the same. Okay, there is a difference. So here we get the user time, which is the one that we are going to use. So in this case, user time was 349 microseconds and then microseconds, sorry. And then this big string is mightily annoying, but let's get past it and we will see the time it took to process the second, this big string. Okay, okay. I of course went too far down. Okay. And then now I'm back up. Okay, let's see if I can just hide this output maybe. Not easily. Okay, let me go back down. Actually, one thing that I can do is just erase anything after that, and that will make it easier for me to check what's down there, okay? Okay, so yes, this way will be faster. So up until here. So the CPU time in this case was 518 microseconds, okay? Which was quite a bit slower, almost double than what I had before. What were the problems here? Well, the problems is that these two functions that I have defined are really not very efficient, okay? And that's shown by the line profiler, which is basically what I wanted to show you today. So the palindrome basically checks whether or not function reads the same in back to front and front to back, okay? And what I'm doing here is that I'm going over all of the characters in the string and I'm checking the one I'm now with the one when I start counting at the back, okay? So when I is 0, this is 0, and this is -1. When this is 1, this is -2. So I'm checking the first character with the last character, the second character, where's the second to last character, and so on and so on. This is not very efficient because I'm going to do it for all the characters. And if I have reached the middle part of the string, I could stop, okay? Also, I'm going to do it anyway, okay? And I'm going to only return false at the end. If at any point I get inside of this loop, this is different, then I already know this is never going to be a palindrome, okay? So I could improve those two things. Contains also checks if one string is contained, if a string S2 is contained in string S1, okay? And it does it in a pretty repetitive and not very intelligent way. I check all the elements in string 1, basically, until string 2 cannot possibly fit it. And then I check if every one of my characters is the first character in string 2 or not. If it is, then I check if all of the others are also the same or not. And then I return whether or not I have been able to reach the end while having the same characters or not, okay? So this also has quite a lot of very annoying unnecessary looping, okay? So how is this reflected in my LP run output, okay? So I get the time that I spent in each of my lines, okay? And as you can see, a lot of my time is spent in the loops, okay? Either in the for themselves or in the if conditions of my loops. And here I have it, okay? Also, the inner parts of the functions also spend a lot of the time that's needed for the functions, okay? You still have time if you want to. I don't have time because I'm about to finish the lesson now, but you can check, improve these things, check the time that it took before the improvements and after the improvements, okay? And see, using the LP run output and seeing where the time and the hits are, see how you can improve this code. You can do some very simple improvements, and with some clever programming, maybe some maps even, you can get an improvement of upwards of 90% to the runtimes of this code. And you can try them with these couple of functions, okay? Finally, there is code to test some how multiprocessor code works, and there are some multiprocessor or multi-thread pools, okay? I cannot explain this here because you need a computer with quite a few processors to run that, okay? And Colab free computers cannot do that. But if you're interested in the subject, this is not something that's super used, but it's very easy. So if you're interested, check these process pool executors and thread pool executors, and you can also submit those. If you don't have time to try them, don't worry. Okay, so thanks everyone for listening. Send me your questions. Remember that the deadline is today. Deadlines are not extended, okay? Send whatever you have today, even if you're not finished. If you finish later, then you can send it to me. I will give you feedback. It will help you for other projects, but it will not count for the grades, at least not with the full weights, okay? I might consider it if someone is very close to the next grade at the end of the course, but the deadline is today and that is not extended, okay? So, okay, thank you very much. And let's finish the lesson today. Any questions, keep them coming and I will do my best to answer. I'm not sure if I will be able to answer before the deadline, but I will try, okay? Thank you very much.